Bell peppers are nutritional standouts, containing more than twice the vitamin C of oranges by weight, plus substantial amounts of vitamin A, B6, folate, and various antioxidants, including carotenoids. The different color varieties, from green to red to yellow and orange, represent different ripeness stages and slightly different nutritional profiles, with red peppers generally having the highest vitamin content. What makes bell peppers particularly problematic from a contamination perspective is their susceptibility to systemic pesticides. Unlike contact pesticides that remain on the surface, systemic pesticides are absorbed through the plant's roots and distributed throughout all plant tissues. This means the chemicals are inside the flesh of the pepper, not just on the skin. Washing, no matter how thorough, cannot remove systemic pesticides. You would have to completely avoid the vegetable to avoid the exposure. Neonicotinoids and organophosphates, common classes of systemic insecticides, are frequently used in bell pepper cultivation. These chemicals are taken up by the plant and incorporated into its tissues as it grows. The purpose is to make the entire plant toxic to insects that feed on it, which is effective for pest control, but creates unavoidable exposure for consumers. Bell peppers also have one of the highest pesticide variety counts among vegetables. Testing has found residues from dozens of different chemicals on conventional bell peppers. The hollow structure with seed cavities can trap residues, and the thin skin offers little barrier to absorption. Additionally, colored peppers, which are sweeter and more attractive to pests than green peppers, potentially receive more intensive chemical treatment. The distinction between field-grown and greenhouse-grown peppers matters. Greenhouse cultivation can potentially reduce pest pressures and allow for more controlled growing conditions, though it doesn't eliminate pesticide use. Hydroponic greenhouse peppers may have different contamination profiles than soil-grown field peppers, though they're not necessarily cleaner depending on the pest management practices used. From a nutritional perspective, you might wonder whether organic peppers have the same nutrient density as conventional. Research generally shows minimal differences in vitamin content between organic and conventional produce, though some studies suggest organic produce may have slightly higher antioxidant levels. The primary difference is chemical exposure, not nutritional value. Cooking methods present an interesting question. Does heat affect pesticide residues? Research shows mixed results. Some pesticides break down at high temperatures, while others are relatively heat-stable. Roasting, grilling, or stir-frying peppers may reduce some surface residues through volatilization or breakdown, but systemic pesticides that have been incorporated into plant tissues are not significantly affected by cooking. For practical guidance, bell peppers represent one of the vegetables where organic purchasing is most clearly justified if you consume them regularly. The systemic pesticide issue means you cannot wash your way to safety. The organic premium for peppers typically runs 50 to 80%, which is substantial but reflects the genuine difference in chemical exposure. If organic peppers are economically inaccessible, consider substitution strategies. Can you reduce pepper consumption and substitute other vitamin C-rich vegetables like broccoli, Brussels sprouts, or cauliflower? Can you use peppers more sparingly as garnish rather than main ingredients? These strategies maintain dietary variety while reducing concentrated exposure to any single crop's contamination profile. For vulnerable populations, including children and pregnant women, bell peppers are a crop where organic sourcing or substitution should be seriously considered given the high pesticide loads and the systemic nature of much of the contamination.